Okay, this is Chapter 8, and Chapter 8 deals with the right triangle. So we're going to be learning how to do Pythagorean theorem. We're going to probably be learning how to do sine, cosine, and tangent, and all sorts of other fun stuff with the right triangle. Okay, so what are you going to need? You're going to need a scientific calculator. And what is a scientific calculator? It's a calculator that contains trig functions. It's got the sine, cosine, and tangent buttons on it, and also the square root function. Okay, and above the sine, cosine, tangent functions, you're going to see sine, cosine, and tangent with a little -1 exponent on it. That just means inverse. We'll learn how to do that in later parts of the chapter. Okay, but first off, let's do some getting started. What is the complement of each angle? Well, the complement is, let's say 23 degrees. It's just 90 degrees subtract 23. Okay, so you got to make sure you've got your calculator handy. I'll do one of these. Okay, so the complement is just 90 subtract 23, and the complement of 23 degrees is 67 degrees. Okay, so you do the other three. So it says calculate the measure of each indicated angle. Now, hint, the sum of the angles in a triangle always add up to 180 degrees, whether it's a right triangle like we have here, or whether it's not a right triangle. It doesn't matter. Any triangle, irregardless of the angles, always add up to 180 degrees, all three of them added together. So I'll do the first one, then you can do the other three. So we've got an unknown angle, one with 71, one with 43. So we take our calculator and we just take 180 and we subtract the first angle, which is 71. It equals, and then we want to subtract the other angle, which is 43, and the answer we have left over is 66. So that means that this angle here is 66 degrees. Okay, so you can do the other three. Use the triangles in question 2. Is the longest side opposite the largest angle? Is the longest side opposite the largest angle? Okay, so the longest side, we've got this one right here. Okay, we can say that's equal to 66 degrees. We'll write it there. The longest side opposite the largest angle. So this is 90 degrees here. That looks like the longest side. These are so close it's hard to tell, but I would say that this, if we took a ruler and measured this side right here, and it's opposite the 71 degrees, it'd be the largest. Looks like this angle here is the largest. And let's do D. Let's do 180 degrees. Let's clear this. 180 subtract 39 equals subtract 62 equals, we get 79 degrees here. So this is 79. Does this look like the longest side? Yes, it does look like the longest side. This looks like the longest side because this is 90 degrees. Okay, right there. So I would say the answer to this question, is the longest side opposite the largest angle? I would say yes, it is. Mark on each triangle with a check mark. Okay, so go ahead and mark it with a check mark, mark it with a check mark, and with a check mark. Okay? Which triangles are right triangles? Well, any triangle that has the symbol with a little square in the bottom is a right triangle. This is the only one. Well, let's see, 45 and 45. Well, this one here is 90 as well. Okay, so we would have to put one right there. Okay, so this is a right triangle, and this is a right triangle. This one is not, and this one is not. So we could say C and B and C. B and C are right triangles because they've got one angle that adds up to 90. Complete the list of square numbers from 1 squared to 13 squared. Obviously, this is leading into the Pythagorean theorem. So 1 squared is 1, 2 squared, 2 times 2 is 4, 3 squared is 9, 4 squared, 4 times 4 is 16, 5 squared is 5 times 5 is 25, 6 squared is 6 times 6, which is 36, 7 squared is 7 times 7, which is 49, 8 squared is 8 times 8, which is 64, 9 squared is 9 times 9, which is 81, 10 squared is 10 times 10, which is 100, 11 squared is 11 times 11, which is 121. 12 squared is just 12 times 12, which is 144. And 13 squared is just 13 times 13, which is 169. Now, how did I know that? It's because I have memorized certain mathematical things to help make my calculations easier. This is one of the things that you could memorize, is squares of the numbers 1 to 13, because it'll make doing other calculations a lot easier and faster. Okay, so square number is this just the result when a whole number is multiplied by itself. Okay, so it says calculate the square root. The first one is done for you. So the square root, you should have a calculator that's got the square root symbol. If you don't know where that is, if you look on here, you can see that there it is right there on mine. Okay, and for me to get the square root, I have to make sure I hit the second function button to get that. Okay, so the square root of 4. Well, it's just the square root of 4 just means what number multiplied by itself twice will give me 4. And the square root of 4, another one I've memorized, is just 2, because 2 squared, or 2 times 2, is 4. The square root of 81, what number multiplied by itself, what whole number multiplied by itself will give me the answer of 81? And that is the number 9, because you can see 9 squared was 81 up here. 0.36. Well, you notice that this 36 is the same as up here, just that the decimal point is in a different spot. Okay, so we can say the square root of 36 has a 6 in it, but it's going to be 0.6. Okay, because if I take the square root, hit the second function square root of decimal 36, I get the answer of 0.6. Okay, 6.76 the square root. Well, just take your calculator, find the square root function on your particular calculator, whichever one you have. I don't know what kind you have, and just put in 6.76 and hit enter equals, and you get 2.6. Okay, and the square root of 5. Okay, let's take our calculator. Let's hit the second function, square root of 5, and we get 2.236067977. Basically, that is one that's probably never going to end. Okay, and that's what we call an irrational number. It has a decimal that never ends, never repeats. So we're probably going to round that off to 2 decimal places. So we'll just say it's 2.24, roughly, approximately 2.24. Okay, let's go to the next page here. What is the inverse operation? The inverse of negative is, well, positive. It's just the opposite. The inverse of x squared is just the square root. Okay, it's the opposite. So, calculate 7.5 squared plus 18 squared. Well, I can do that on my calculator because it has order of operations built into it. So if I want to do, I'll move my calculator over here to the side. So if I want to do 7.5 squared plus 18 squared, I'll do 7.5, and I'll hit my square button, and I'll do plus 18 squared. My calculator does order of operations for me, so I don't have to worry about calculating 7.5 squared individually, separately, and then adding it to 18 squared separately, writing them down. My calculator will do it all, and I get an answer of 380.25. 380.25. Okay, so your calculator, if you have a decent one, should be able to do order of operations. It'll do bed mass, brackets, exponents, division, multiplication, addition, subtraction. So it'll probably calculate this first, and then that, and then it'll subtract one from the other. Okay, so you can go ahead and do this one here. Compare, write equal to or not equal to. This means not equal to. Okay? Okay, so 5 squared, 3 squared is 3 times 3 is 9, plus 4. Okay, 9 plus 4 equals 13, and 5 squared is 25. Now, is 25 equal to 13? No, it is not equal to 13. Okay, now why did we do that? Well, because we've got 3 to the exponent of 2 plus 2 to the exponent of 2. So you would just think you could just take 3 plus 2 is 5 and put it to the exponent of 2, but notice that it doesn't work that way. 13 does not equal 25. Okay, 4 squared is equal to 5 squared minus 3 squared. Okay, well, 5 squared is 25, minus 3 squared is 9, and 4 squared is 16. And 25 subtract 9 is 16. Whoop. So it is, sorry, I put it is equal to. Okay, so 4 squared is equal to 5 squared minus 3 squared. Okay. 12 is equal to 4 squared minus 2 squared. Well, 4 squared is 16. 4 times 4 minus 4. And 16 subtract 4 is 12. It is equal to. Okay. And this D here. Square root of 36 plus 64. We have to do BEDMAS, so we have to add 36. We have to do brackets first. B is brackets, so we have to add 36 plus 64. Okay, so we take our calculator, and we can do 36 plus 64 equals 100. So we want the square root of 100, and the square root of 100 is equal to 10. So 50 is equal to 10? No, 50 is not equal to 10. Okay? So solve for x. Check by substituting your answer into the equation. So 2x equals 24. So 2 times some number equals 24. 2 times what equals, this is where it's really important to know your times tables. So 2 times 12 equals 24. Okay? X over 3 equals 15. Well, how do we do that? Well, what we can do is we can learn how to do something called cross multiplication, or we can think in our mind what number divided by 3 will equal to 15. Well, what we can do is we're going to cross multiply. We just take 3 times 50. We can take x times, if we put this over 1, we can say x times 1, which is x, is equal to 3 times 15, which is 45. So 45 divided by 3 is 15. So this is equal to 45. We can do it by cross multiplying, or we can just do it in our head. Okay? X is equal to the square root of 121. So we just take our calculator, put in square root symbol of 121, and we get an answer of 11. And the square root of 169 is equal to 2x. Okay? Well, we know the square root of 169 is 13. So we end up with 13 is equal to 2x. So 2 times what number is equal to 13? Well, we can just take 13 divided by 2 in our calculator. 13 divided by 2. And we get an answer of 6.5. So 6.5. X is equal to 6.5. Okay? For safety, a ladder should be at least 1 foot from the wall. So it's got to be right here, 1 foot from the wall, for every 3 feet of ladder. So that means that for every 3 foot tall the ladder is, it's got to be 1 foot away from the wall. So we have a ratio of 1 to 3. How far should the bottom of a 10-foot ladder be from the wall? Well, we have to have a ratio. The ratio is the distance from the wall, length of the ladder. So 1 to 3, distance from the wall to 3, as question mark is to, or x is to, well, we want to be 10 feet away. Okay, so the question is, how do we solve for that? So what we can do is we can do what we did up here. We can cross multiply. We can take this times that. Cross multiplication means we go across but opposite. If the 1 gets multiplied by the 10 and the 3 gets multiplied by the question mark. Okay, so 1 times 10 is 10 is equal to 3 question mark or 3x. Okay, how do I solve for that? Well, it's 3 times what number equals 10. Okay, so if I divide this to get rid, I want x is equal to, I want to get rid of the 3. So if I divide that by 3, because any number over itself, 3 over 3 is the answer, is 1, I have to divide the other side by 3 as well, because what I do to one side of the equation, I have to do to the other. These 3's cancel, so I get x is equal to 10 divided by 3. This is very simple algebra that you've already learned in grades 7, 8, and 9. And therefore, x is equal to, we just take our calculator and we do 10 divided by 3 equals 3.33 repeating. Okay? 3.33 repeating. So how this 10-foot ladder should be approximately 3, and decimal 33 as a fraction is 3 1/3. So 3 1/3 feet from the wall. Okay, a little about 3 foot 4 inches. 11. What is the area of the composite shape? Okay, area is equal to 4 times the area of a triangle plus the area of a small square. So you can see in the picture over here, we've got 4 triangles. There's a triangle there, and there's another triangle there, and here's a triangle here, and here's a triangle here. They've broken up the square into 4 triangles that are equal, and then there's this square in the center. So what is the area of the composite shape? It says the area of is 4 times the area of one triangle. So there's 4 triangles, so we have to find the area of a triangle, and the area of one triangle is just the base times the height divided by 2, times that by 4 because there's 4 of them, plus the area of the small square. Now it says that each square is 1 centimeter squared, so it's 1 by 1. Okay, and that means that this square here is just 1 times 1, which is 1. So we're just going to add 1 to it. We're going to add 1 centimeter squared. Okay, so base times height of each triangle. Well, the base is 1, 2, 3, 4. So the base is 4. And we're going to multiply that. That little dot means to multiply. And the height, if I go 4 that way, I'm going 1, 2, 3 this way. So it's 4 times 3 divided by 2 times 4 plus 1. Now 4 times 3 is 12. 12 divided by 2 is 6. So this 4 times 3 divided by 2 is 6. I multiply that by 4. This should be a little dot here. Times 4. So 6 times 4 is 24. Plus 1 is 25. So this is 25 centimeters squared. Area is always in units squared. Okay, remember that. What is the length of each side of the larger shaded square? What is the length of each side of the larger shaded square? Of the larger shaded square. Oh, right here. They want to go from here to here and from here to here. Well, how do we do that? How do we go the length of each side? Well, basically what we do is we have to take the length of the side squared is equal to the area of the square. So the key is that it tells us that it's a square, which means that this side is the same as this side, is the same as this side, and the same as this side. So the whole area, because it's a square, is 25. Okay, so the area is equal to 25 centimeters squared. So the length, that means that this side times this side equals 25 because they're equal. So we can say that the length of the side, the length of one side, is just equal to the square root of 25, which is equal to 5 centimeters. It's a length, so it's just in centimeters. Okay, so it's the square root. That means that this length here is 5 and this length here is 5. Okay? All right, that's all there is for getting started.